everyone, welcome back to hmlearnings. I am Harshita, the creator of hmlearnings, where students come to clear their concept and to get the study material. Make sure you subscribe our channel. So we are back with the next video on the respiratory physiology. That is, the title of today's video is the conversion between STPD, ATPS and BTPS. So this is a very interesting topic of respiratory physiology. It is a fundamental topic of respiratory physiology, and in this topic we are basically going to see that how the volume of gas changes with the change in the conditions like temperature and pressure of the surrounding. So from this video onwards, we have started that we are going to put a question at the end of every video, and that question will be related to that particular video, and you will be asked to answer that question in the comment section. So by this we will know that how much you actually get out of our video, and this will also help you in making your understanding more clear about the topic. I said that today's video is about how the volume of the gas changes with the change in the conditions like temperature and pressure. So here T stands for temperature and P stands for pressure, and these two parameters, temperature and pressure, is basically what is changing in these three atmospheric conditions. So let's start the video. So the fundamental concept behind this topic is that the volume of the gas changes with the change in the surrounding temperature and in the surrounding pressure. So what does it mean? It means that if you are having a beaker of air, and in this beaker you have actually taken 1 liter of air, and the temperature at this time is 30 degrees Celsius, and you have taken this beaker to somewhere where the temperature is not 30 degrees Celsius but 35 degrees Celsius. So what will be the volume of gas at this temperature? So the volume of the gas will not be 1 liters. Here it will be different from the 1 liters. So this shows that the volume of the gas changes with the change in the temperature. Similarly, if you fill the beaker at 1 atmospheric pressure and you taken it to somewhere where the pressure is around 0.9 atmosphere, at this time also the volume of the gas will not be 1 liter, but it is different. So this shows that the volume of the gas changes with the change in the surrounding conditions, that is change in temperature and change in pressure. So what stays constant? The quantity which stays constant is basically the moles of the gas, and we know that mole of gas is basically 1 mole of gas is equal to 6.0 to 200 raised to power 23 molecules. So the mole of the gas is basically telling that how many molecules of the gas are present, and this quantity is basically remains constant even though there is change in the temperature or pressure. So even if you are taking 1 liter of gas at different pressure and temperature and your volume is changing, but your moles of gas is going to be constant irrespective of temperature and pressure and volume also. So now we will understand these three conditions. What does it mean? What is the full form of it? So STPD is called as standard temperature and pressure dry. ATPS is called as ambient temperature and pressure dry. BTPS is called as body temperature and pressure saturated. So what does the standard temperature means? It means a pressure, standard temperature means it means a temperature of 0 degrees Celsius or 273.15 Kelvin. What does the ambient temperature means? It means basically the temperature of your ambience. Maybe it is temperature right now, and we suppose we take it for this video as 30 degrees Celsius. So how do we calculate the ambient temperature in the Kelvin? We plus the 30 degrees Celsius with 273.15 Kelvin. This is how we are going to get it in the Kelvin. And now we know the body temperature is constant, which is 37 degrees Celsius. So you plus 37 with 273.15, you get 110 Kelvins. Now, what is this pressure dry? So pressure dry at standard temperature, STPD is basically your 1 atmosphere, and it is basically dry air. So what does a dry air means? We know that air is a mixture of different gases, and this, like, we know that mixed air is a mixture of gases. It includes oxygen, nitrogen, and other gases. So likewise, it is possible that your water is also present in the form of the water vapor in the gas, and this makes your air humid. So if we are saying that the air is dry, it means that the humidity is 0, and this is possible at temperature of 0 degrees Celsius where there is no water vapor in the air. So at this point, we call this air as dry air. The partial pressure of water vapor is 0 and the humidity is 0. So here this pressure of a dry gas is 1 atmosphere. Now, what is ambient pressure? Ambient pressure is going to be the dry pressure at that particular temperature, which is calculated as 1 atmospheric minus the partial pressure of water at that particular temperature. So if we are saying that 30 degrees Celsius is the temperature right now, we are going to know that what is the partial pressure at 30 degrees Celsius, and we are going to subtract that partial pressure of water from 1 atmosphere to get a pressure of dry gas at that ambient temperature, because we are using the dry pressure for calculating the volume of the gas. We are not using the pressure of water vapor also. So we are going to subtract the water vapor pressure at that particular temperature from the total atmospheric pressure to get the pressure of a dry gas. This is what we do at the body temperature also. What is the partial pressure of water at 37 degrees Celsius is going to be subtracted from 1 atmosphere to give you the body pressure of the dry gases. So now we will move on to the next slide. So basically, how we calculate the volume of gas is by using the ideal gas equation, which is called as PV is equal to nRT. This is basically based on the assumption that you are calculating the volume of an ideal gas, which means, what is ideal gas? Ideal gas is basically as an assumption that the gas molecules are not interacting with each other. There is no intermolecular interaction between the gas molecules. This is an assumption, and based on that assumption, you are getting an ideal gas equation, which is called as PV is equal to nRT. Now, how do we use this formula? We are going to see next, and how we drive this formula we are going to see at the end of this video. So now we will move on to understand that how the temperature, how the pressure change is going to change the volume of the gas, keeping the mole of the gas constant. This shows you 3 different conditions: STPD, ATPS and BTPS. So STPD means the standard temperature and pressure, dry. ATPS is ambient temperature and pressure, saturated. BTPS is body temperature and pressure, saturated. So first of all, we are going to calculate if we are taking 1 mole of gas at STPD, that is the temperature is 273.15 Kelvin and pressure is 1 atmosphere. So at this particular condition, what does the 1 mole of air, what is the volume of 1 mole of air, 1 mole of gas here? So PV is equal to nRT is the formula we are going to use. Pressure we know is 1 atmosphere, volume we need to calculate it. Number of mole we know is 1, then we multiply 0.0821 into temperature, which is 273.15, and from this you get the volume of the gas as 22.4 liters. So this shows that 1 mole of gas at STPD occupies 22.4 liters. Now we will see that at ATPS, like if you are changing the temperature to ambient temperature, which is 303.15 Kelvin, and you are changing the pressure to the ambient pressure, which is 0.9581, after subtracting the partial pressure of water at 30 degrees Celsius, you are getting this dry air pressure, and you are going to use it in the formula PV is equal to nRT, keeping the moles of the gas constant, that is 1 mole of gas. So what will be the volume of 1 mole of gas at ATPS? So PV is equal to nRT again. P is 303.15. Volume of gas we need to calculate. Number of mole is 1. R value we already know, 0. This is the value, and the temperature. So from this, the volume of the gas which you get is 25.96 liters. So 1 mole of gas at ATPS acquires or occupies 25.96 liters, whereas 1 mole of gas at STPD occupies 22.4 liters only. So there is a change in the volume of the gas which has been acquired at different settings. This is what we have already discussed, and this is how we have proved it. Now what happens at the body? In the body, what happens? So we are putting the conditions inside the body, which is the temperature as 310.15 Kelvin, pressure as minusing, we are going to subtract the partial pressure of water 37 degrees Celsius, which is 0.062 from 1 to get a dry air pressure at body temperature, and the number of mole is the same, only 1 mole of gas. So again the same formula, and we are going to put all these values here. 0.938 into volume, 1 into the multiplication of this will come as 25.46. So what you get it as 27.14 liters. So as the temperature is increasing, as the pressure is decreasing, you can see that there is expansion of the volume of the gas. So there is basically increase in the volume of the gas. So even though your mole of the gas is constant, is the same in these three scenarios, the volume of the gas is different. Now this is the volume of a mixed gas, that is, it has all the gases, but if we want to see the volume of one gas. So if we want to calculate the volume of oxygen, like in this 22.4 liters of the gas at STPD, what is the volume of the oxygen? So in that case, we know 21% thing. So 21% thing means that it is a volume percent, which means that if you are having 100 liters of mixed gas, 21 liters of gas will be your oxygen. So if we want to calculate the volume of oxygen, we can do the 21 percentage of 22.4 liters, which will come as 4.7 liters. Okay. Similarly, we can calculate the nitrogen also, which is 78% of 22.4 liters, and this will come as 17.4 liters. Now what will happen to the volume of the oxygen and nitrogen at different conditions? Like what will happen to it at STPD? So again, here also it will be 21% only. 21% doesn't change with a change in the pressure and the temperature conditions. So 21% of 25.96 will come as 5.45 liters, and for nitrogen it will come as 20.24 liters. So you see that it's not the volume of one gas which is increasing with the change in the temperature and the pressure. It's the volume of both the gases, oxygen and nitrogen, which is changing. And if you see what happens at the BTPS, the same thing is going to happen here also. With using 21% of 27.14 liters for oxygen, you get it as 5.67 liters, and for nitrogen you get it as 21.16 liters. So you see that it's not the volume of a single gas which is changing, it's the volume of all the gases of a mixture which is changing. And that is how you are seeing that as the temperature and pressure is changing, the volume of individual gases also changes, and the volume of mixed gas also changes. So what will happen to the mole of the oxygen and the mole of nitrogen with the change in the temperature and the pressure? So as the law suggests, the mole of the oxygen and the mole of the nitrogen is also going to remain the constant with the change in the temperature and the pressure. So how does it happen? Okay, is it true? We are going to see it by calculating it. So we know that basically that your at STPD 4.7 liters of oxygen are present. ATPS it is 5.45, and at BTPS it is 5.67 liters. So what is the number of oxygen moles at these three conditions? We will calculate that and see that is it the same or it is different. So here we are going to use again the PV is equal to nRT formula. And we know all these things, we know the volume also, but we have to calculate the number of oxygen moles here. And this is all we are going to put it, all the values, and you can actually calculate it by yourself, and you're going to get the answer as 0.21 moles. Okay, so as you know, you remember the 21% thing. So here also, it is not only the volume percent, but it is also the mole percent, because you know that the whole gas is around 1 mole, is 1 mole. So if you calculate the 21% of 1 mole, you get it as 0.21 moles, which is also being calculated here. So this shows that it is true for, it is 21% is volume percent also, and 21% is mole percent also. Now we are going to see what happens in the case of the ATPS. So again, putting the same things. Okay, so here if you again you calculate it, as I directly put the things here to save the time. So if you calculate this thing, you will get it as N is equal to 0.21 moles. So you get the same thing out of it. And here also, if we just to save the time, I am writing it directly here also, you will get 0.21 moles. So you put these things, I mentioned it here, you can pause the video, you put these things in the formula PV is equal to nRT, and you will get the same number of moles of oxygen in all these three conditions, even though the volume was different. This shows that the mole of the gas remains constant. It is just your volume which is changing with the change in the pressure and the temperature. So you know about the tidal volume, which is 500 ml. It is basically the volume of air which is breathed in and breathed out at rest, and this is the volume is being given at the BTPS. So this 500 ml of air is going to be different at ATPS and different at the STPD. So now if I want to calculate that what is the mole of the gases which is present, the mole of mixed gas which is present in 500 ml of air. So how can we calculate it? Again, by using the PV is equal to nRT. If you put all these things, 0.938 is the atmospheric pressure at BTPS. Volume of the thing is 0.5 liters. Number of moles of mixed gas is something which we wanted to calculate, and I'm going to put these values. So by putting these values, the number of mixed moles of gas which you get is 0.0184 moles of mixed gas which is present in 500 ml of air. So at rest, if I am taking 500 ml of gas which is present inside my lungs, it is containing 0.0184 moles of mixed gas. And if I am interested in knowing that what is the mole of oxygen which is present in this, I can easily put the 21% thing again. So if I calculate the 21% of 0.0184, I can get the number of oxygen moles at 0.0038 moles of oxygen which is present in 500 ml of air at BTPS. So this is how you can use this PV is equal to nRT. And if I want to know that basically what is the volume of the gas of oxygen which is containing 0.0038 moles of oxygen at BTPS, I can also do it by putting it into the PV is equal to nRT. And by that means you get the volume as 0.102 liters, that is 102 mls. Okay, and if you calculate the 21% of this 500 ml only, you can get it as 105 ml. So these values are near only. So this means that 500 ml of air, if I am taking at BTPS, if the 500 ml of it is there, in that 100 ml of air is basically oxygen, which is having 0.0038 moles of oxygen. This is very interesting to know. Now I have told you that there was one formula, PV V1 divided by T1 is equal to P2 V2 divided by T2. So how does this formula come? So basically we know this is the formula. Okay, and we know that this is constant. Number of moles in R is basically constant. So we can put it like this, and we can put it as a constant. Now if these values are for one condition, so like if I say that 1 is basically the ATPS condition and 2 is basically the BTPS condition, and for 2 also the N and R are basically constant only. So by this means I can equate this equation and I can get this equation. Okay, so you can easily convert the gas volumes between these three different states by using this formula. You need to just put your pressure and volume, pressure, temperature, and you can have the volume in different scenarios. So this is how this formula is being used. So as I said in the starting of this video that we are going to give you a question. This is the time for telling you this question. So we wanted to know from you that how much 500 ml of gas at BTPS occupies at ATPS if you are taking it as 30 degrees Celsius temperature and at the STPD. You have to mention it in the comment section and also let us know that what will be the number of oxygen moles at these three different conditions. This is a tricky question. So these are the references you can look upon for further details and further understanding. If you like this video, please like, share and comment your answers. Till then, keep learning.